I would like to ask to the front Evelina Domnitch and Dmitry Gelfand, who worked with the quantum computing team of QProx. No, I'm mistaken here. The quantum computing team of RysQ, which is based at the University of Amsterdam. So please show us what you have brought. You brought an object. We're very curious about that. And after that, they will be interviewed by the director of Kapelice Gallery in Ljubljana, Jurij Krpan. So please give them a hand.
Thank you very much. I'm so happy to be part of FEED project because Dmitry and I have been working with scientists since the beginning of our creative collaboration for a very long time. And the FEED project, so before it was this kind of partisan work, really breaking some borders and sort of acting as an atomic icebreaker, but this time it's really like flying a spaceship. So we just came from FED meeting of RysQ group, which is quantum computing group, and it's Rydberg atoms quantum simulations. And it seems like something you will never comprehend, but actually it's the device that we brought you is one of the simplest devices you can ever build. And this is the most precise device. This is a device for which Wolfgang Paul, who invented it, got a Nobel Prize. So we will ask Jurij Krpan to assemble it, because he comes from the land of Tesla, and this is a high voltage device. Good. But this conference, where we had a privilege to listen to the presentations of the top quantum physicists, was so eye-opening, and the scientists were so eager to see the interest from normal people to what they do, and to discuss a lot of, human questions, whether the instruments of quantum physics are the extensions of our senses, or are they really unveiling objective reality. And it is very difficult to talk in the space. I can see how you are trying to hear it, because this environment is extremely dissipative, and I want to start dancing and like synchronizing to this now when it will go back, because I want to start self-organizing the space. And this is the problem with quantum computing, that you can only do it on the level of individual atoms, where the entropy is so minimal. And when you have the environment, like this environment, so let's say Ars Electronica really works on the geological scale. This building is the scale of a geological object, and to make sense with our small temporality is quite difficult. So I try to use some self-organization. So we go to the object.
So although it is very tight,
maybe you can talk a little. Yes, you can show it around and make it, try to arrange it and make sense of
it. It sort of looks like an Egyptian hieroglyph, but it is actually an ion trap. It is what allowed humans for the first time to isolate a single atom.
And the very important thing is the distance. So the distance between these balls that are electrodes should be the radius of this ring from the center, and then you will get a very strong electric field that acts as a shield where you can keep a single atom or a single ion. And of course, the scientists, they create vacuum around it, because the environment is interfering too much We will do it without the vacuum, just like this, with lycopodium spores and with microspheres. And lycopodium spores is like these tiny particles floating in air, and actually this building is saturated with this kind of dust, and the wonderful Anna was already talking about the dust and microorganisms, and I'm very happy that artists are zooming in into this very important domain of action. So these little spores, these little particles, 20 micron, you usually cannot see them, but when they are trapped in this electric field that acts as a shield that holds them there, and they oscillate, they dance, and the dance is actually the visualization of electric field. And we shine a laser on it, and they become brightly visible. They become extremely visible. And something that will come out of this project, another artwork that will be beyond feet, we call it aerobiome. So we'd like to start this kind of citizen science projects where people bring samples of air from different parts, from wherever they want, from the center of the city, from the mountains, and we put it in the ion trap and light it with a laser, and you can see what lives in the air. Of course, again, the container is a big problem because you always need an ion trap, so everything in the air will stick to the walls of the container. But we're working on it.
Yes, and it's also important to note that you will not just be seeing the trapped matter in this configuration. We're also creating an optical projection without any kind of video, without any kind of recording device. You will be able to see these tiny interactions blown up to a meter size.
Just optically. So why is quantum computing so important? Because when you go on and why we kind of strive to get to quantum computing so much? Because of course when you go on the scale of atoms and up and down, so the kind of the characterization of these tiny particles are so that they are already digital. You have up and down, you have this digital, so it's almost a digital system, and it's so small. So we had this talk yesterday with Tommaso Calarco at this conference. So he said, I can never be able to build a quantum computer the size of a cat, so Schrödinger cat, because there are too many atoms, too much matter. But with a quantum computer, you can have a computer. So you can have, just with a few atoms, you can do really complex computations. And this is in a way how, where in the universe you can tap in the most abundant sea of energy. It's vacuum, it's elementary particles. And there are two different, let's say, directions of particle physics. So there is high energy particle physics, CERN, and we've been there recently too, and you guys have been there too. And it's really very daunting and inspiring. But this other group of physicists, the optic physicists, who work with very small setups and who manipulate individual atoms, their understanding of reality with this very efficient experimental setups is not less than what is going on in the high energy physics. And for us, so what is going on is this second quantum revolution, where the Thought-Gedanken, the thought experiments of Einstein, where you can really imagine how you would manipulate single atoms, were just, you know, a play of imagination. And today, scientists are doing it because of this little ball trap. And this, with this little device, was possible for the first time manipulate individual atoms, individual ions, and do the most precise mass spectrometry. So to measure, to feel, to understand what atom really is. And we feel extremely privileged that we could share our thoughts and work together with such a group of thinkers and physicists, and how open the were. And we have the most exciting project coming up, which is probably will be already outside of feet, because it will take a little bit more time. And this is...
Yes, this is a place perhaps where even though quantum physics has been such an extraordinary success for approximately a century, some significant philosophical problems remain as to how to actually observe, how to envision quantum behavior. And they're not too far away from here, in Innsbruck, there is an ion trap that the Dalai Lama visited and saw with his naked eye, along with 100 other individuals.
Less people that travel to space, which is about 550. So about 100 people on this planet saw a single atom with their eye, with the retina, without a microscope. And this device is in Innsbruck, in Austria. So we are working together with this group to make this kind of an experiment into an art installation. Thank you.
Okay, well, please, Jurij, interrogate them.
Yes, please.
Yeah. I'm just one question, which is a little bit
Speak up.
A large one, but I'm strongly believing that artists and scientists are going along well. Since a scientist's way of thinking is linear, and artist's way of acting is synchronous. You know, so artists are addressing all the senses, so you can grasp things beyond your reason. You know, like Klebnikov is saying, za umno. No? And this is where my question is coming in. By not having a project which is just science communication, but an art piece. So what are you bringing on the table in the lab when you are when you will meet scientists with your artwork?
First and foremost, we believe that the physiology of the senses, the elasticity of human perception, is such that it can be tuned to grapple with this immense philosophical problem, that we haven't the faintest idea what occurs on the most fundamental scale. We have some hints about reality, but at bottom we require some calibration, some tuning. And I think that there is no more imaginative, more fertile means than through art. That is one of the reasons why some nearly 20 years ago, Evelina and I started engaging in art as a means of investigating these innards of reality. Something that, very few, just to add to that, unfortunately very few astronomers look through telescopes anymore. It's usually the data coming from telescopes immediately lands into the virtual domain. But we want to bring the senses, the sensuality back into this philosophical paradigm.
So yes, I agree with Dmitry. We bring the human retina to the lab, and this also raises a question: why do we do science? Why, as humans, do we do science? To create more sensitive machines, to create better technology, or to create these methods, these distilled ways of behavior that allow human being to develop? And I think we do art and science for this reason, to allow human beings to evolutionize.
There is just a small little still that it's bothering me, because as an artist, you need to develop your sensitivity in order to be sensitive enough, But on the other side, you are having scientists that very often are coming back to you with, yes, we know it's beautiful, we know it since the beginning, it's fascinating, So how to really tune them, that they come into the philosophical and experiential level of getting into.
Well, I think that scientists already are doing there, and the problem is not with scientists. The problem is bringing this knowledge and these mechanisms of tuning perception, tuning human mind to a broader public. And I'm very happy that some artists have this courage to approach scientific discourse, because there is this horrible misconception in the general public that science is so difficult you can't understand it. But in fact, we have science to make things clear. And we have to, scientists already, they start to believe that science is incommunicatable, that it's boring, that their senses are dull. But this is not the case. They are in the avant-garde, and we have to share it with the rest of the humanity, or at least create such avenues that will give these tools to more normal people. It's just education. I think otherwise, as a scientific technological society, we will be a utopian, dysfunctional project, just like this building.
Thank you for that. Thank you, Jurij, Evelina, and Dmitry.